In 1992, construction workers in San Diego uncovered something that shouldn't exist. Bones of an ancient creature, broken with precision, surrounded by stones that showed unmistakable signs of being used as tools. But here's the problem. According to science, there were no humans anywhere near North America at that time. Not even close. What they'd stumbled upon would challenge everything we thought we knew about how humans populated our world. This discovery would spark one of the most intense scientific controversies of the modern era, a debate that continues to rage more than 3 decades later, pitting respected researchers against established dogma and forcing us to question the very foundations of what we believe about human history and ancient migration patterns. It started like any ordinary Wednesday in November of 1992. While a Caterpillar excavator tore through the earth along State Route 54, a highway expansion project cutting through a hillside south of San Diego, where the city borders the smaller community of National City. The construction crew didn't expect to find anything remarkable that day. They were simply doing their job, widening the freeway to accommodate the ever-increasing volume of traffic that flows through Southern California. But then something caught the eye of the paleontologists who were on site monitoring the excavation. This was standard protocol for major construction projects in California. When you're moving massive amounts of earth, when you're reshaping the landscape and potentially destroying geological records that have been preserved for millions of years, you need experts watching for fossils that might get crushed and lost forever in the process. And that day, their presence would prove to be historically significant in ways nobody could have anticipated. A paleontologist named Richard Cerruti spotted something unusual in the freshly excavated dirt. Bones. Large bones protruding from the sediment layer that had been exposed by the heavy machinery. As the team began carefully extracting the material, taking their time to preserve every detail, they realized this was no ordinary find. These were the remains of a mastodon, an extinct relative of the elephant, that had roamed North America tens of thousands of years ago, an imposing creature that dwarfed modern elephants and represented the apex of megafauna that once dominated the continent. But this particular mastodon's bones told a story that nobody expected, a narrative written in the patterns of breaks and fractures across ancient bone. The team, led by paleontologist Thomas Desmarais from the San Diego Natural History Museum, began a meticulous excavation process. They unearthed the remains of what appeared to be a single adult male mastodon. The bones they recovered included 2 massive tusks, 3 molars, 16 ribs, multiple vertebrae, portions of both femurs, phalanges, and over 300 bone fragments scattered throughout the dig site. But it wasn't just the quantity of bones that made this discovery remarkable. It was the condition in which they were found and what that condition seemed to suggest. It was how they were broken. The way they were fragmented told a story that seemed impossible. Many of the bones showed evidence of what scientists call spiral fractures. These distinctive breaks occur only when bone is fresh, still containing moisture and organic material, still containing the proteins and minerals that give bone its characteristic structure and strength. Dried bone doesn't fracture this way. It shatters differently, in a more chaotic and random pattern. The spiral fractures observed on the Cerruti mastodon bones suggested these bones had been deliberately broken while the mastodon was freshly dead, possibly within hours or days of the animal's death, when the bone still retained its organic character. But the real discovery came when the team noticed something else entirely. Mixed among the bones were 5 large stones, cobbles that seemed out of place in the fine-grained sand deposits. These stones weren't randomly placed. They bore unmistakable signs of use and wear that suggested purposeful application. Some showed impact marks that looked like evidence of percussion use. Others displayed what looked like damage consistent with being used as hammers or anvils to break bone. The implications were staggering and profound. If these bones had been deliberately broken by human hands, using these stones as tools, then humans had been present in North America far earlier than anyone believed possible. But extraordinary claims require extraordinary evidence, a principle that guides scientific inquiry. Desmarais and his team knew that simply announcing a discovery like this would invite immediate and intense skepticism from the scientific community. Scientists would demand proof, would question methodology, would suggest alternative explanations. They decided to take their time, to conduct rigorous testing, to explore alternative hypotheses, and to build what they hoped would be an airtight case before going public with findings that would overturn established scientific consensus. The excavation continued for months, from November 1992 through early 1993. Every artifact was carefully documented, photographed from multiple angles, and cataloged with precision. The team brought in experts from around the world to examine different aspects of the discovery and to lend their specialized knowledge and experience to the investigation. They called in Dan Fisher, a renowned paleontologist from the University of Michigan who had spent decades studying bone accumulations and who specialized in mastodon and mammoth fossils. Fisher had examined sites across the world where these ancient animals had clearly been processed by humans, where the bone damage patterns told stories of ancient hunting and butchering practices. He studied the spiral fractures on the Tsuruti mastodon bones and examined the impact marks with the careful eye of someone who had seen thousands of similar bone deposits. He came to a conclusion that shocked even the researchers who had invited him to examine the evidence. The evidence of percussion breakage was undeniable. These bones had been deliberately processed by something with agency and intent. But processing bones is one thing. Proving conclusively that humans did it is quite another. The team needed to rule out alternative explanations systematically and methodically. Could heavy machinery from the highway construction have caused these fractures? Could natural geological processes explain the patterns they were observing? Could taphonomic processes, the post-depositional changes that affect bone over time, account for the damage? They brought in Dr. Richard Fullegar, an expert on stone tool use wear analysis from the University of Wollongong in Australia. Fullegar was one of the world's leading authorities on identifying whether stones had actually been used as tools, whether the damage patterns on stone surfaces reflected human agency or natural processes. He examined the 5 stones from the site under magnification, studying every surface detail and scratch mark. He compared them to known stone tools from well-established archaeological sites. He also conducted experiments, deliberately breaking fresh elephant bones with similar stones under controlled conditions to see what patterns emerged and what signatures of human tool use looked like. Fullegar's analysis supported the hypothesis that the team was promoting. The wear patterns on the Tsuruti stones matched what you'd expect from stones used as hammers and anvils to process bone over extended periods. The impact marks were consistent with percussion use, and the microfractures on the stone surfaces resembled those created during bone-breaking activities. But still, the team knew skepticism would be intense. The mainstream scientific community was deeply invested in the conventional timeline of human arrival in the Americas, and this discovery would challenge that investment. They spent years conducting additional tests, gathering more data, and seeking out additional expert opinions. In 2014, 22 years after the initial discovery, scientists from the United States Geological Survey used uranium isotope dating on the mastodon bones. This technique measures the decay of uranium atoms incorporated into bone material after death, using sophisticated geochemical principles. It's an extraordinarily precise method, capable of accurately dating materials up to 500,000 years old, and it had been refined and improved considerably since its initial development. The results came back with striking clarity. The bones were approximately 130,000 years old. Specifically, 130,700 years ago, give or take a margin of error that was statistically small. The mastodon had died during the last interglacial period, a time when Earth's climate was warmer than the present day, when sea levels were significantly higher and when the Bering Land Bridge connecting Siberia to Alaska was completely underwater. In fact, according to current geological models developed over decades of research, it would have been physically impossible for humans to walk across that land bridge at that time because it didn't exist. If humans really had been in San Diego 130,000 years ago, they either arrived far earlier than anyone believed and survived in the Americas for hundreds of thousands of years, developing cultures and communities across multiple continents, or they possessed maritime capabilities and sophisticated boat technology that allowed them to travel across the ocean, a level of technological sophistication that seemed to odds with the archaeological record from that time period. Finally, in 2016, after nearly a quarter century of research, testing, and peer review, the San Diego Natural History Museum team submitted their findings to Nature, one of the most prestigious and influential scientific journals in the world. Nature's editors and peer reviewers examined the evidence with extreme scrutiny, applying the most rigorous standards of scientific evaluation. Scientists who had no connection to the research and no vested interest in the outcome independently assessed the findings. In February 2017, after months of careful review and deliberation, they made their decision. The paper was accepted for publication. The world would finally learn about the Tsuruti mastodon site and what the researchers believed it revealed about human history. On April 27, 2017, the news broke across the globe. Headlines around the world announced that humans might have arrived in the Americas over 100,000 years before previously thought. The media coverage was intense and widespread. Major news organizations ran stories on their front pages and in prominent positions. Social media exploded with discussion and debate. Scientists were interviewed on television and radio programs. Thomas Demiray held a press conference at the San Diego Natural History Museum acknowledging the audacity and boldness of their claim. He said, "I realized that 130,000 years is a really old date. Of course, extraordinary claims like this require extraordinary evidence." The team believed they had provided exactly that kind of evidence. evidence that met the high standard demanded by their extraordinary claim. But within hours of publication, within a single day, the scientific community erupted in fierce and passionate debate. This wasn't the enthusiastic embrace of a groundbreaking discovery that revolutionized understanding. This was immediate, intense skepticism, mixed with outright dismissal. Paleontologists and archaeologists who had built entire careers on the accepted timeline of human arrival in the Americas found themselves suddenly questioned. Geneticists who had published studies supporting the conventional dates were challenged by colleagues. Universities that had taught the standard narrative for generations were now dealing with uncomfortable questions from students and colleagues who were grappling with this new information. The consensus that had seemed solid suddenly felt less certain. The core of the skepticism centered on several key points that critics articulated clearly. First, there were no human remains at the site. No bones, no teeth, no skeletal material, no evidence of humans themselves. Critics argued that if humans were truly butchering mastodons here in groups, why wasn't there any trace of them? Second, there were no other artifacts typical of human archaeological sites. No traditional stone tools, no evidence of fire use, no hearths or fire-cracked rocks, no domestic tools, just these 5 stones and the broken bones. Third, many archaeologists questioned whether the stones were really tools at all. Could they have been naturally accumulated and broken by geological processes? A former Caltrans surveyor named Farrell offered an alternative hypothesis that gained some traction among skeptics. He suggested that the heavy earth-moving equipment used during highway construction could explain the observations. The steel teeth on the excavator bucket could have dragged cobbles across the site, and vibrations from dump trucks could have caused the spiral fractures. He proposed that what scientists interpreted as intentional human processing was actually collateral damage from industrial construction. Other critics pointed out logical inconsistencies in the human activity hypothesis. If humans were intelligent enough to butcher large animals using stone tools, if they had the knowledge and skill to process a mastodon, why didn't they leave behind any other evidence of their presence? Why no hunting camps? Why no other food debris from other animals they must have eaten? Why no evidence of shelter or domestic structures? Why nothing that would suggest a sustained human presence over time? The Clovis culture, which existed only about 13,000 years ago in North America, left abundant evidence of human habitation, including distinctive spear points that archaeologists could identify with certainty, cut marks on animal bones showing characteristic patterns of human butchering, and campsites where tools and bone refuse accumulated. Yet here, in deposits supposedly 100,000 years older, there was virtually nothing except these few stones and mastodon bones. The absence of evidence seemed to weigh heavily against the hypothesis. Prominent and respected archaeologists published responses in peer-reviewed journals, raising their concerns about the methodology and conclusions. David Meltzer, a leading expert on First Americans archaeology, who had published numerous influential papers on the topic, expressed serious doubts about the interpretation. He and other researchers suggested that the site needed more rigorous examination and that alternative explanations hadn't been adequately ruled out. In the journal Antiquity, researchers from Harvard University and other institutions outlined their concerns about the experimental methodology used to support the human activity hypothesis. They questioned whether breaking fresh bone with cobbles really produced the same pattern of fractures observed at the Taruti site. They wondered whether the experiments adequately replicated natural processes in weathering that might create similar-looking damage patterns. John McNabb, a Paleolithic archaeologist from the University of Southampton in England, published a detailed commentary in Nature asking pointed and difficult questions. He noted that the site's lack of other evidence of human presence was striking and difficult to explain under the human activity hypothesis. If people had been living in North America 130,000 years ago, where were they? Why had no other sites from that period been found despite intensive archaeological surveys across North America? Why was there no gradual accumulation of campsites and artifacts that would inevitably result from hundreds of thousands of years of human habitation? The absence of evidence, while philosophical convention suggests it's not proof of absence, was nonetheless striking and troubling. Other researchers questioned the dating methodology itself, suggesting that while uranium isotope dating is sophisticated, the assumptions underlying the technique might not hold in this particular case. They questioned whether uranium uptake in the mastodon bones could be accurately modeled. Some suggested that the bones might have been exposed to uranium-rich groundwater, potentially skewing age calculations. These were technical criticisms that spoke to the fundamental reliability of the dating evidence. The San Diego Natural History Museum team responded to each criticism methodically and patiently. Thomas Desmarais and his colleagues published response papers addressing specific points raised by skeptics. They addressed alternative explanations for bone fractures by presenting geological evidence about site formation. They noted that while heavy equipment might cause some damage, the specific pattern of spiral fractures was harder to explain through construction. They pointed out that stones showed wear patterns inconsistent with being dragged by machinery. They addressed the lack of human remains by noting that human bones rarely survive in extremely old deposits. They found an analogy in the Clovis culture, which, despite being a widespread archaeological culture found across North America, had produced only 2 known human skeletal remains, across thousands of sites. They argued that the absence of human bones at the Cerruti site, while unusual, wasn't necessarily fatal to the hypothesis of human presence. They conducted additional experiments to refine the comparison between bone damage from stone tools and damage from other sources. They published detailed geological analyses of the site formation processes. But acceptance from the broader scientific community remained limited and cautious. Some researchers remained open to the possibility, willing to consider that human presence in the Americas might have occurred earlier than currently accepted. Others called for more research and more evidence before drawing firm conclusions. The mainstream position among first Americans archaeologists remained that the site was interesting and worthy of continued study, but the evidence was ambiguous. Alternative explanations couldn't yet be ruled out definitively, and the data for human activity, while suggestive and intriguing, fell short of being conclusive and convincing. The controversy continued intensifying through 2017 and 2018 as more papers were published in various scientific journals. Some supported the Cerruti hypothesis with additional analysis and research. Others critiqued the methodology or raised alternative explanations. In 2018, the San Diego Natural History Museum mounted a comprehensive exhibition about the site at the museum in Balboa Park. Visitors could see the actual mastodon bones and the 5 stones that were proposed to be tools. The museum presented both the evidence for human activity and the detailed criticisms from skeptical archaeologists, giving visitors a sense that this was an active scientific controversy rather than a settled matter. The exhibit read, "The Cerruti mastodon discovery reveals the earliest evidence of human life in North America." But the tone suggested that this evidence was contested and that the scientific community had not yet reached consensus on its meaning. The years that followed saw continued research, debate, and analysis. Some new evidence emerged that seemed to support the Cerruti team's interpretation. Analysis of the stone wear patterns using advanced microscopy showed features consistent with bone breakage activity. Experimental archaeology comparing the damage patterns to known human processing sites and to damage created by machinery showed interesting similarities and differences. The team also commissioned additional geological and taphonomic studies examining whether natural processes could explain the bone fractures without invoking human activity. Their findings suggested that natural processes were unlikely to produce the specific pattern of damage and wear observed on the Cerruti bones. However, skepticism persisted among mainstream archaeologists. Every new study supporting the Cerruti interpretation was met with responses questioning its conclusions, its methodology, or its implications. Critics argued that bone breakage from stone tool use, especially from events that occurred hundreds of thousands of years ago and left such limited evidence, was difficult to diagnose with certainty. They noted that similar fracture patterns could potentially result from various geological processes, from the weight of overlying sediments, or from natural weathering and degradation over time. They pointed out that the experimental studies being conducted were based on assumptions about ancient conditions that might not reflect actual conditions at the site thousands of years ago. By the early 2020s, the Cerruti mastodon site had become what one researcher called a Bretz-type controversy, a reference to J. Harlan Bretz, a geologist whose revolutionary theories about catastrophic flooding and glacier outburst floods were initially rejected and ridiculed before eventually being proven correct and accepted by the mainstream scientific community. The comparison suggested that the site might eventually vindicate Desmarais and his team, but only after more evidence accumulated, after new discoveries were made, and after scientific attitudes shifted to accommodate new possibilities. Alternatively, future research might definitively disprove the human activity hypothesis, explaining the bones through natural geological processes, through construction damage, or through some other mechanism that didn't require human presence. The implications of the discovery, if validated, would be genuinely revolutionary for our understanding of human history. The conventional model of human arrival in the Americas posits that people crossed the Bering Land Bridge approximately 15,000 to 20,000 years ago, during the last glacial maximum, when sea levels were substantially lower and the land bridge was exposed and traversable. This model is supported by extensive archaeological evidence from sites across the Americas, by genetic studies of Native American populations, by radiocarbon dating of numerous archaeological sites, and by a general absence of credible evidence for human presence before 15,000 years ago. A 130,000-year-old site would overturn this entire model. It would suggest that humans, or possibly pre-modern hominins like Homo erectus, were capable of long-distance maritime travel and ocean crossing much earlier than currently believed. It would imply that these ancient peoples managed to establish populations in the Americas that survived for hundreds of thousands of years, adapting to changing climate and developing distinct cultures. It would mean that the entire history of human presence in the Western Hemisphere needed to be completely rewritten. All the archaeological theories built on the conventional timeline would require reassessment. All the genetic models of Native American ancestry would need revision to accommodate multiple migrations or earlier entry dates. University textbooks would need to be updated. The very foundation of First Americans archaeology would fundamentally shift. This is precisely why the scientific community has been so skeptical of the Cerruti claims. The discovery asks archaeologists and geneticists to overturn a well-established model based on a single site with contested evidence and ambiguous interpretations. In science, the burden of proof for extraordinary claims is genuinely extraordinary. A single site, no matter how carefully studied, is usually not sufficient to overturn a consensus model supported by hundreds of other sites, by multiple lines of independent genetic evidence, and by the absence of any other evidence supporting earlier human presence in the Americas. Yet the possibility remains intriguing to many researchers. What if the Cerruti team is right? What if humans or human-like creatures really did migrate to the Americas over 100,000 years ago? What if there were thriving populations here for hundreds of thousands of years and then they mysteriously disappeared, leaving behind almost no trace except for this single site near San Diego? The mystery deepens when you consider that there have been other discoveries over the years, scattered reports of potential evidence for early human presence in the Americas, that never quite convinced the mainstream scientific community, but suggested gaps in our understanding. The Cerruti Mastodon site thus stands at the intersection of possibility and skepticism, of revolution and caution. The evidence seems suggestive of human activity, but it's not conclusive. The alternative explanations are plausible, but seem to strain credibility in the face of careful expert analysis. The broader implications are so significant that skepticism is scientifically justified. Yet the possibility that we've fundamentally misunderstood when humans populated the Americas cannot be easily dismissed or ignored. Today, the site remains controversial and contested, a puzzle that archaeology has yet to solve definitively. What's particularly intriguing about the Cerruti controversy is what it reveals about how science actually works, how paradigm shifts occur, and how entrenched ideas can resist revolutionary new evidence. The scientific method demands that we test hypotheses, gather evidence, and follow that evidence wherever it leads. Yet scientists are human beings with biases, with investments in existing theories, and with institutional commitments to established frameworks. The Cerruti case illuminates these tensions beautifully and painfully. It shows us how difficult it is to overturn established consensus, even when the evidence is carefully gathered and methodically presented. The site also reminds us that human history is far more complicated than any simple narrative can capture. We know that humans have always been adaptable, creative, and capable of extraordinary achievements. We know that ancient peoples were intelligent and resourceful. We know that migrations and population movements have occurred repeatedly throughout human prehistory. The question isn't whether early humans were capable of reaching the Americas or developing sophisticated technologies. The question is what the evidence actually shows and what reliable conclusions we can draw from that evidence. For now, the Cerruti Mastodon site remains open to interpretation. Research continues, new analyses are published regularly, and debates persist in academic literature. The San Diego Natural History Museum maintains its exhibition, preserves the original materials, and continues to support scholarly investigation of the site. Graduate students study the site as a case study in archaeological interpretation and scientific controversy. Universities continue to teach about the discovery as an example of how science handles extraordinary claims. Whether the Cerruti site ultimately proves to revolutionize our understanding of human prehistory, or whether it becomes a cautionary tale about misinterpretation and overinterpretation, remains to be seen. What seems certain is that the careful work conducted by Desmarais and his team has contributed something valuable to our scientific knowledge. Whether that contribution is confirming evidence of very early human presence in the Americas, or a detailed case study in how natural processes can create patterns that superficially resemble human activity. Either way, the site has earned its place in archaeological and paleontological literature as one of the most significant and contested discoveries of recent times, a testament to the fact that even after centuries of systematic study, we still have much to learn about human history, ancient migrations, and the deep past that shaped our world and our species.